Hi everyone, great to be here. Thank you for the introduction. I think that my lecture really complements Kirk's lecture because actually I'm gonna focus more on the scalability aspects of ZK rollups and opportunities they bring to oracles, and not the privacy related opportunities. So those are two very different kind of line of thoughts, and they all merge together in this ZK rollups. So before we get into what is L2 and why I think it has great benefits for a ZK for an Oracle solution, let's take a step back and discuss the entire blockchain industry state. Now is the true moment to understand how the clicker works. Where's the clicker? Yeah. Sorry. Okay, it was the big red button all along. So Bitcoin was launched in 2008 and Ethereum in 2015 with the promise to build an alternate economy to what we've had so far. But many years later, we are still frustratingly slow compared to traditional finance beasts, right? Like banks, credit cards, etc. So why is that, and why is that inherent, right? Why can't we have something more scalable? In the days of the traditional economy, we had trusted parties, right? Banks, lawyers, accountants, and so on. And everyone trusted them to do the computation correctly for us, and we have delegated accountability. And then blockchain came and said, okay, let's not have delegated accountability, let's don't trust, verify, right? Everyone knows all the transactions. And as a result, we broadcast all the transactions to all the nodes in the network. And yes, we earned the fact that we don't have to trust anyone, but we lost two very crucial things, right? One is privacy, because everyone knows all the transactions. This is what Kirk mainly talked about. And the focus of this lecture is going to be the fact that we lost the scalability, right? We just see that Bitcoin and Ethereum are several orders of magnitude behind any traditional economy creature. And why is that? Why can't Ethereum designers turn tomorrow morning, get up and say, let's increase every block by 100, right? We'll have much more transactions, much more throughput. Is this solving the problem? Or are we just stuck in this current state of affairs when we have to either trust someone or operate in a very slow network? So the sad truth is that if we were to increase Ethereum by a factor of 100 this way, a lot of the networks that currently tracking Ethereum make sure that everything is in line wouldn't be able to keep track of Ethereum anymore, right? Because the speed of the network is 100 times faster. So the sad truth is that in any layer 1 design that requires you to know all the transactions in order to verify yourself the network, the more performant you become, the more you require from everyone to verify. And as a result, the less such de facto verifications happen, right? So if we were to multiply Ethereum by a factor of 100, not so many full nodes, and the network is less secure. And we see basically all the layer 1 designs sitting on this scale, right? Some of them, like Ethereum, choose to be very, very secure and less performant. Others choose to be more performant and less secure. But obviously, we want to work on as a secure platform as possible, especially when we design oracles, right? Even with the best oracle design, if you work on a flawed network, nothing basically saves us, right? We are doomed. So let's focus on the more secure edge of the scale on Ethereum and see why it's problem not in only terms of the transaction cost, right? Or not only in terms of the throughput, but also in the designs that Oracle force themselves to have when they operate on Ethereum, right? Because the sad truth is that gas is expensive, and gas is expensive because not a lot of gas can be there, not a lot of gas can squeeze in. And every decentralized application, but even more so oracles, need to mind the gas constraint and design solutions that would work with very, very low amount of gas. And this is really crippling, I think, for any economical system, what we see currently on L1. Like the handicap that oracles need to put on themselves. Let's start with frequency, right? I take Chainlink because they are like the leading, I think, de facto most used oracle. They update their measure feeds, Bitcoin and Ethereum, every hour, right? Hour is a very long time, or sometimes they update a bit more frequent than that if there was like a very major price shift. But compare this to like a centralized exchange, right, where prices updated on a seconds basis, and you have like huge market makers with very, very sensitive prices and a lot amount of money, right? You can't compete with that. We can't create the Ethereum to create this many volume if we have once an hour updates. And I think the update situation is even more bad, right? Because when you need the updates the most is when you have a lot of price shift, right? And then the network is the most congested and you have even less price updates. So the fact that price updates arrive only every hour or so is crippling, but more than that, the diversity, right? If updating the price of an asset costs you a lot of money, these assets need to prove itself as a very useful asset to report on, right? Because reports cost money. You can't just put a token and expect that everyone would suddenly start to provide prices for. And more than that, even beyond the frequency and the versatility of prices, the aggregation logic itself is like, it's always median or time-weighted, time average weighted price. And like, why is that? We have a lot of aggregation logic, and for some use cases, much different logics would make sense. And median wasn't chosen because it's the best, right? It was chosen because it's the best condition on have very, very low gas cost for verifying it. So we see that L1 is like, it's very important, right? Because it's very secure, but it's crippling from the economical perspective, right? You would like to have many, many updates. You would love to have updates on more assets. You would love to have more diversity in how we aggregate price feeds. And I think that like I focus on oracles, but this is true for any decentralized application, right? So every decentralized application designer makes choices to consume as low gas as possible on the expense of being economically efficient or just having more features. So why is that? Like how can we improve the situation, and how can we stay in the security of Ethereum but actually have a system with a lot of throughput? So the right way to do it, as you might have guessed, is with validity proofs. We actually see example for like very naive validity proofs in our day-to-day lives, right? When you go to the grocery store, you get a receipt. The receipt is basically a proof to the claim you need to pay us such and such. And in order to verify this claim, you need to repeat the entire calculation, add all the numbers up, and make sure that it makes sense to you. But with zero-knowledge Stark proofs, in addition to the privacy, which Kirk talked a lot about, and I would ignore in the rest of the lecture, we gain scalability. Because what happens is, think about going to the grocery store and buy 1 million items. But now it's enough to make 10 additions, and you can be sure that you indeed paid the right amount, right? So this sort of like scalability where to verify the computation, you only make exponentially smaller amount of work, is really a game changer, right? Because now we can take the blockchain models that we've seen before, right? Where you have a lot of nodes that want to verify themselves that whatever going on in the network is secure, that no one really cheated them. And instead of telling them, here are 1 million transactions, you tell them, okay, here is a proof that 1 million transactions were executed correctly. And in order to know it, they only put amount of work equivalent to 110 transactions. So you get the best of both worlds, right? You can have very, very strong computers, like few supercomputers, that can advance the network in the rates we see at like networks like very performant networks, and still preserve Ethereum level of security, right? Because the full node doesn't need to repeat whatever the sequencer is doing, right? It doesn't have to really process hundreds of transactions per second. It's enough for him to just verify a zero-knowledge proof, and then he can say, okay, I don't know what were all of these transactions, but I know that they were run faithfully. And this is what we do at Starkware. We actually execute this technology in real life, and we currently have 2 validity rollup solutions. One of them is StarkX, which is like application-specific. We like prove a very specific logic, like NFT minting or spot trading or perpetual trading, which actually requires an Oracle price feed to know what the external prices are. We offer several orders of magnitude improvement in gas costs compared to L1, and like it's very, very stable. And we also have StarkNet, which is like a blockchain that we currently build. It's in very early stages, but the magic of it is that it supports general computation. So you can write your own smart contract for StarkNet. It's very, very similar to Ethereum. You can interact with other smart contracts, be fully composable, and be sure that whatever crazy logic you write there will prove it, and the cost itself would be minimal. And we already see a lot of applications and Oracle solutions that come to Starknet to see what they can do and what limits they can break. And I think that especially for oracles, this computational environment of ZK rollups actually make a lot of sense. Because each computational environment is built on optimizing different things. And with validity rollups, right, we are not like a Filecoin, right? We don't overly optimize storage. But what we do optimize well are two things. It's computation, and it's the amount of inputs you have. So computation is just because to verify your proofs, you still need exponentially smaller amount of work, right? So computation on layer 2 is really, really cheap. And also the amount of input that you have doesn't really matter to the transaction cost. Imagine a transaction that gets like 100 price feeds from 100 sources with 100 signatures, and it verifies all those signatures, and it does some potentially extremely complicated calculation on those 100 base numbers. And in addition, it reaches like a final number, which is the final price, and this is the storage that it writes. This transaction would be very, very, very cheap in a validity rollup environment, because in the end, L1 doesn't care like how much computation you had, what was the size of your input. Even if you want the entire state to be available on L1, as rollups often do, you still need to know only one number, right? The final representation of the price, right? It doesn't matter that you inferred it from like 100 different sources. And this is why I think a lot of applications, and in particular oracles, have a lot of opportunities. But the year is 2022 and not 2015, so it's about time I bring some evidence to what we can actually do. So let's look on some case studies. And the first case study I want to mention is DYDX. So we partnered up with DYDX several years ago to build a perpetual scale platform on layer 2. And before going up with us, they had 10x leverage. They offered like single assets, short or long positions. And the transactions were pretty costly. And after we onboarded them on layer 2, yes, we improved the cost by several orders of magnitude. But what's more crucial to this lecture is actually not this, but the first 2 points. First, notice that the leverage went from 10x to 25x, and we also added new features, right? And how is it come we were able to do it? It's exactly the new opportunities that layer 2 environment allows you to have, right? Because in DYDX, we partnered up with Chainlink as an Oracle price provider, and they actually provide DYDX prices at a frequency of several times per minute for every asset. This is something unheard of in the L1 space. And this is what allows DYDX to offer leverage that competes actually with centralized exchanges. Not like you can't give such high leverage as an Ethereum application, you just can't. And the second feature that we had is the ability to do like a long or short positions on many, many, many assets in parallel. So I can, with the same collateral, say I bet that Bitcoin would go up and Ethereum would go down, and I don't know, like tens of other bets using the same collateral. And it's not inherent, right? We could program it in Solidity. Solidity is a perfectly good language. But on Solidity, it would push up the transaction cost of DYDX from 100K to 300K. So it's just not worth it. And they settled out on not having this feature in their first version. But on a more computationally tolerant system or environment, suddenly it's possible, right? So they have this new use case. And so this is like a StarkX example. But we also see a lot of such examples in Starknet, actually much, much more example, because Starknet allows anyone to just write and build his own smart contract. So for example, we see a lot of games. On layer 1, traditionally what games did is they said, okay, we keep our entire logic off-chain, and on L1 we just store the assets, right? We just store the NFTs. Why? Because logic is so expensive on L1. We can't have any operations that the player does in a game translates into transaction, not even in a ratio of like 1 to 1,000. It's crazy. And what we see with Starknet, just like I expect to happen with oracles, is that games are able to move more and more of their logic on-chain and sell to the players, okay, yeah, in the old design we did everything off-chain because it was too expensive, but suddenly now we ported over all the parts that we did off-chain to Starknet, And the additional cost is so low that it makes sense for us to do it, right? Because the marketing value suddenly surpasses what I have to pay for the network in order to do it. And this not only proves that like Oracle's and decentralized applications has great potential over Starknet, I think that it only serves as an opportunity for Oracle's, right? Because the more applications you do that are doing crazy things, the more custom data feeds those applications need, right? If I suddenly say, okay, now I have an option market. Option is another example to a great primitive that on L1 is just too expensive to be economically efficient. If I have an option market, if I have stable lending, if I have like pawn shop, suddenly those are new use cases for Oracles which are like out of bounds from the traditional, here is the current price of Bitcoin. And those can be like monetized, and Oracles and applications can really work together to fit out what really makes sense for those applications. And the most crucial thing here is that not only all of this happens on L1 security, right, because everything is backed by the security of Ethereum, is that we are practically unlimited in the amount of use cases we can have. And this sounds a bit weird, right? Even if Starknet is like the most robust network out there, probably it wouldn't handle, I don't know, 1,000 TPS. So how can I claim we are unbounded? So here, in this context, zero-knowledge proof is the silver bullet that can solve us everything, actually. Because what if we implement a verifier for a zero-knowledge proof as a Starknet contract, right? Suddenly we have another new layer of computation that we can do, and then this layer of computation proves itself to Starknet, right? So whenever Starknet not enough, we can just say, okay, let's build another one on top of it, and on top of it, and on top of it, and have this massively tree of blockchains where every blockchain just proves its correctness to the blockchain beyond it. Everything is anchored to Ethereum security, right? You don't have bridges between networks that might break if like the other network is broken, right? Like we've seen with like Cosmos and Luna, for example, right? Where chains that had bridge to Luna suddenly suffered. So we see here really unlimited potential to how much we can grow this ecosystem. And I think that the community recognizes it as well, because this is like from 2 months ago. Since then, I guess there are a lot of more projects that just joined the train. And this is like both StarkX and Starknet ecosystem. And you can see like many projects, many use cases. One particular project that I love to talk about is Snapshot that you can see there. So we're actually partnering up with Snapshot to build up a voting platform. So every decentralized organization can vote on Starknet with very low prices while still have on-chain level of security in their voting, which is insane. And as I said, those applications bring new opportunities for Oracle, right? If we have very sophisticated lending platform, it would need a lot of price reports on many assets. It would need to be very frequent. It would need to be resilient. And different oracles would solve those sophisticated needs in very different manners, right? And each oracle would have its own approach potentially. And you'll have use cases not on L1 like stable lending, pawning shop, really more and more. The sky is the limit here. And also in terms of like aggregation logic, right? You can have something much more sophisticated than median. I'm not really sure what it would be because I'm not an Oracle guy, but I know that Starknet for sure can fit something much more complex there is, and I'm sure that people out there in the traditional economy don't use median, or at least not always use median or time-weighted average price as a way to know the price. So like, I think that this is just the beginning of a journey. Zero-knowledge proofs were something that was like unheard of a few years ago. And I think that it's really fascinating to see how more and more people join this cart and build a lot of zero-knowledge blockchains. Like Starkware is not the only space in this company. As we have a lot of talented people really doing the impossible, and a lot more people that joining this trend and like bringing what we can do with blockchain to a new heights. So I'm really curious. I'm curious what decentralized applications and specifically oracles will be able to do and create when we give them like very scalable environment with general computation, composability, and Ethereum level of security. We'll also be decentralized hopefully next year. Thank you.